I'm Jackie Faherty, and I'm an astrophysicist and astronomer at the American Museum of Natural History. And I thought I'd take 5 minutes to tell you about this fun, cool paper that I worked on over this year period, which answers a question in some ways: what extrasolar worlds could find Earth? So we've just left the ocean and now we're talking about space. I think that's a really good connection, sea to space. And this is based on a Nature paper that we just had accepted, but it's embargoed still. So whatever that means, keep it in the room. So this paper came from the idea that right now there's just over like 4,300 planets, exoworlds, that we know of that astronomers have detected, and they range in all sorts of properties. But 70% of those worlds have been detected through a method called the transit method. That's a method whereby you look at a star and you wait to see its light dim ever so slightly as the planet passes between your detector, your eye, and the star. And you see it go around, it does it a couple of times, you think, bingo, I've got something, and you catalog it. So 70% of the worlds that we know, it's a really efficient method. And so we're constantly wondering, okay, how many worlds, how many worlds, how many worlds are out there? So myself and Lisa Kaltenegger decided to reverse the question, reverse the vantage point. Instead of asking how many worlds are out there, we asked how many stars are currently in the bleacher seat stadium side place where they can see us, Earth, as a transiting world. And so, uh, I prefer to give this talk in a planetarium, but this is Zoom, so what can I do? This is a movie I rendered for you. That's the sun, and you might be thinking, that's a lot more stars than I'm used to. And it is, because I used a catalog of stars that are precisely mapped. They're very, very precisely mapped. It's called the European Space Agency's Gaia catalog, and everybody should know about it because it's humanity's greatest mapping mission. And so all the stars that we're just on were all there's 500,000 within 300 light years. There's over almost 2 billion of them that we've mapped in this one catalog. And all of the stars you see there lined up are in that position, the perfect position. They can look our way and see Earth transit in front of the sun. And so we found that there were about 2,034 of these objects. And we didn't stop there with our question. It wasn't just who can see us right now, because seeing us for a second doesn't help because you have to watch us for a while. So here's the catalog again. It gets you excited. That's the map. That's where the stars are. We asked a second question. We said, okay, well, how long can they see us for? And so that's this movie that I've rendered for you, where I'm kind of flying away from the sun again, and I'm hanging out here at probably like 30 light years away. And I'm going to turn time on. And so now I'm moving time forward at like 10,000 years a second. So you're watching how the stars actually move over time in the local vicinity of the solar system. They're whipping around in all sorts of ways, shapes, and forms. So you could very well show up in a vantage point, see Earth transit, and then all of a sudden you're off. Your angle's off and you don't see us anymore. So our conclusion was that we had found, by doing this trick, I took time and I moved it backwards, and then I moved time forward. And I said, over the past 10,000 years, what stars see Earth as a transiting planet? So back to this view again of this catalog came on. Here's Earth. There's the sun over there. This was to give you that aesthetic of seeing it all together. And we found that there are that highlighted collection of stars now that looks lined up right there. They're lined up. That's stadium seating right there, man. And some of them stay there for a really long time, and some of them zip through the zone. So there's 2,034 of them. 7 of these have planets around them. 7 of them we already know have rocky worlds. Some of them have looked at us in the past. Some of them, TRAPPIST, for instance, a very famous exoplanet hosting star, is about to look at us. And it's about to look at us. It has 7 rocky worlds around it. It's about to look at us for 1,600 years or something. It'll see us for a while. So do you think you want to be found? I mean, I think about this. This is actually a question that came into my mind. And to end with this idea too, with my 15 seconds, there was a lot of news that was out there about this object Oumuamua being alien probe, alien spacecraft, whatever, blah, 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 blah. I'll give you my honest take with a lot of honest scientists' take. It's a nice rock that's flying around that came from another solar system. It's very exciting, but I don't think it's an alien spacecraft. However, it's a fascinating idea. Would you send probes? So the closest objects that can see you at the technology that we have, we're even thinking of doing this with Proxima Centauri, the closest planet that we've found thus far. These are the worlds that see us. So we have generated this catalog and really asked the question, and you should reflect on it too. Do you want to be found? That's, I guess, how I'm going to leave it. But we have a catalog that would tell you if you could be.